Chat. There we go.
Okay. Hi, everyone. Today we are, for the folks on YouTube, we are discussing chapter 6 of Deep Learning with Python. This chapter is all about the universal workflow of machine learning. The slides were produced with Claude, it's Claude's assistance, so very grateful to it. Um, this chapter has no code in it, really. There's no code cells. I don't even know if there's a Colab Jupyter Notebook for this. It's all about, I guess, the business process of taking a business need, modeling, uh, defining the problem as a modeling problem, and deploying your solution, your machine learning model, whether or not it's a deep learning neural network, and maintaining it, I guess, and iteratively developing on it. So, yeah, let's get into it. And feel free to jump in, interject at any time with comments, opinions, concerns, whatever you like. So the big picture of this chapter is that we have three phases to any machine learning workflow. Again, this is not just for deep learning. This applies to all machine learning. And really, I think at a conceptual level, any data science work you're doing, you're just trying to define the task, which is step one, develop a model or a process more generally. And three, you need to deploy the model, deliver it to stakeholders. These are the three steps that are in this workflow as per the authors. And I guess the thing to take away here is that machine learning in the real world does not start with nice, neat data from the Keras data sets or from Kaggle or like another online source. You're going to expend blood, sweat, and tears, or someone is understanding the business problem, collecting and annotating data, um, and then deploying your model. So I think I've seen this elsewhere that machine learning, like writing the code and like refining your model and deciding what uh, architecture of neural network to use, like how many layers and all that, like that is actually a relatively small part of the project, I suppose, in like scope, brain power, and time. A lot of it is in defining the task, which is the first part we'll talk about. Um, when you have stakeholders coming to you asking you to do things with machine learning, statistics in general, you need to know what is the input data, what data will feed your model or your process, and what are you trying to predict, or more generally, what kind of metrics or statistics, summary statistics, if you're doing like a simple ad hoc analysis, are the stakeholders looking for. You have to think about what type of analysis this is. Is it a machine learning task at all? But is it binary classification, regression, and so on? One thing that I'm definitely guilty of is not considering what existing solutions are in place, not only to learn from them, they've paved some of the same road you're trying to pave, but also because you have to, I guess, beat those existing solutions, ideally with any machine learning model you are creating. And lastly, what constraints exist for latency, so speed, privacy, what device will your model be deployed on? Um, this is basically framing the problem, taking the business considerations in your scope. This is just a table Claude came up with to match certain project types to task types. We've seen this elsewhere in the chapter or in the book, excuse me, that hint at some of these same links where a photo search engine is multi-class because I get these confused, multi-class and multi-label. Multi-label means that a single image can have multiple labels. I can't remember what multi-class, oh, just that there's more than one outcome, like it's non-binary. Is
Yeah,
that correct?
yeah.
Okay. Okay.
Dog, cat,
Horse,
truck.
whatever. Yeah.
Yeah.
Okay. Okay. The simpler form, binary classification, spam and not spam. This chapter talks about matrix factorization for as a tool for music recommendation models. I have never heard of that before. I'm not sure if anyone has anything insightful to say about that. And then I won't go through the rest of the table, but basically you're just trying to wade through the muck of your business problem and simplify it to a deep learning approach or a machine learning approach.
I have heard of that matrix factorization thing. I vaguely remember that it exists. That's about it.
Okay. Okay. Hey, that's more than me.
It is a well-known technique, but I forget how it works
Okay.
exactly.
Okay.
Period. I was
Is
gonna
it,
say
do you know if it's used for anything beyond, like, is its niche really music recommendations?
I don't know. Yeah,
Okay.
I don't
Okay.
remember.
No worries.
I mean, it's singular value decomposition is a mathematical technique, so that's used for a lot of things. But in terms of machine learning, I don't know if that is applied to, that particular way of using it is more general. Or I don't know.
Okay. Maybe I'll pause here just because I feel like I'm being slide heavy. How do you guys like if you want to talk about it, how do you normally get projects? Like, are they clearly defined? Are they vague? Um, do you have like formal checklists to follow these processes, or do you just go where your intuition leads you?
I mean, I just thinking the last project I did, it was like we started with one data set that we spent a lot of time and money on that. That got us nowhere. It was like what he was saying, we couldn't actually get the you couldn't really learn what you wanted out of it. So then we spent a bunch of money on a different data set. That turned out to be great, but it also changed how we're going to approach the whole problem. So I mean, it's not a checklist for me. It's kind of like go this way, that's wrong. Go this way, that's promising. We'll keep going that way, So yeah, for sure. And then like the different types of technique that turned out to be more of a statistical learning, not deep learning type problem. But we had thought about we might have been using deep learning, but then we saw the data, we realized this is, actually this data was so good we could have, or I should say not so good, but very compatible with like ordinary types of regression techniques and things. So that worked out well. But
Okay.
yeah, no checklist for me. Maybe I
I will
should, but
I can say like we do use a very formalized like data science intake form where I work.
Okay. Nice.
But half of the time the stakeholders don't really have enough data literacy or data experience to really complete it fulsomely. So actually you end up really having many engagements with them over time, over and over and
yeah.
over to work through that intake form to get to a process where everybody's sort of understanding the problem. Um, and I would say over the last 5 years, like I've devoted more and more time actually to that upfront process because it ends up saving you time down the road. And it's usually a couple cycles at least of, okay, we think we understand everything, but do we really? And then going back again to all the questions. Yeah,
No,
literally
that's
every section of this chapter, although it wasn't like no new concepts, it was very groan worthy for me in being like, oh God, yes, all of these are true problems. Like
Yeah.
getting a data set, getting everybody understanding what they're trying to actually do. Half the time they don't actually know what they're trying to do. Um, and as Ron said, sometimes you've made an underlying assumption that the data you've got is going to do the job or has the signal in it, and it doesn't.
Yeah, we spent a lot of time going back and forth, not only with the stakeholders, but also with the people providing the data,
Oh,
because there's
yeah.
things that they, in their documentation that says one thing, and that doesn't seem to hold up in the data. So you go back to them, and wait a minute, we did this cross check, like, oh yeah, we changed that.
Yeah,
It was actually
Yeah,
one
I
of these
get
cases
that
where
all the
they
time.
changed it like midway through the data collect too. But this is
right.
like years and years of data collect. That happens, right? The standards evolve. Like, oh, we
Yeah.
should start collecting this now. Let's move everything around. So you have to like We had to write
Yeah.
a lot of code just to ingest this data. Like we
Yeah.
have a ton of code that we were very careful to make reproducible and everything, so that we could always
Hmm.
just take all the data raw from them, and then run it through this big code base and get it into our own cross-check database. But that took a lot of cycles. I mean, that was actually, I would say that was at least 50% of the work on that project. That was
Yeah. Yeah. Yeah, totally. We also have like a, a model intake, like a model form, like that we sort
oh,
of curate and keep. Like, what version of the model is, what are the inputs, what are the output? Like, so there
that's
is
a
a
good
model
idea.
form. Like we are trying to standardize some of this now. Like that's becoming like there's more models deployed. But um, in its infancy, I'd say. But I can see like once you've got a lot of models fly on the fly, going, or you want to hand off model maintenance to somebody else, the value of that documentation becomes better. Yeah. Also, in my case at least, we have to tie the 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 value of the model to some kind of organizational value, like save time, money, that kind of thing. And it
Oh,
needs to
okay.
be clearly defined up front what you're going to get from it, and quantified basically at the end. Like how much money have you saved? How much time have you saved? That kind of thing. So, for example, if you're trying to speed up a process, it's like we're going to speed up this process 80% with the model, and then you just, sort of at the end tie it back to that anticipated impact. Anyways, just to say, yes, we have an intake, and it's a long process, walking people through it.
I'm curious. We don't have that kind of. Well, the only formality we have for models is the models are captured in code, so it's like a GitHub repo, and then
Hmm.
things are version controlled and tagged and all that. But yeah, that's an interesting idea. Like a form that highlights some of these other aspects, like oh, what's this model supposed to accomplish? What's the goal? What's the tie back to benefit? Right,
Yeah, well,
that's a good
for
idea.
example, you'll declare your benchmarks and your
Yeah.
required retraining criteria, that kind of thing in them.
Oh,
So, like, because a lot of these things have a compliancy requirement, or some kind of audit requirement, like if some of my models start drifting beyond this threshold benchmark, I have to retrain them. Because we've agreed as an organization, like if we're doing a certain kind of prediction, that we are going to be within a certain margin of error. So when that error is hit, like I gotta do something. So that's all captured like in that kind of documentation, like what we've decided the accuracy, like just throwing out a possible metric. What does the accuracy have to be?
right.
That kind of thing.
All right, so yeah, I actually haven't had to do that. Most of the things I'm doing are kind of like, hey, this is kind of a proof of concept for a future program type of thing. It's
Yeah.
like go one step, but you're actually out there with things deployed, being used. So yeah, you're actually putting in practice the things in this chapter. That's really interesting.
Yeah, certainly the in production section was interesting to me too, because like that is a not a barrier, but like that's stuff that's still being built out, like the stuff to do the deployment, and like that deployment looks different than training. It can actually be much simpler. Uh, and then how you set up your deployment, like is it another system calling yours, or are you running it in-house kind of thing?
Right,
And I'll say for like most of the healthcare stuff, it's got to be pretty tightly locked down and controlled if you're using data with PHI, like sensitive data in it. It has to run on site basically. It can't be REST API. It can't be hosted on the web kind of thing. Anyways, I'll stop talking now. You can continue.
Okay.
yeah,
No, no, that
that's
was all
really
good. Thank you.
informative to me. Yeah.
Um, okay, to get back on the horse here, two key hypotheses I suppose you're making when you embark on, you think you understand the business need, the business context, and you go out to try to make a model, take your inputs, get outputs. Your two hypotheses are that targets can be predicted from inputs. Um, I think this is about if you like future stock prices are not well predicted by previous stock prices. Um, so I guess there's like this theory of information thing where like, can you actually predict the output based on what data you have? And then that your available data is informed enough. I'm taking that to mean the data is of sufficient quantity and quality to inform your model, to help your deep learning model suss out the patterns to do like a multi-class problem, for example. If anyone had different interpretations of that, let me know.
No, I think that's, yeah.
Ethics note, good to keep in mind. Technology is never neutral, as per the author's words. Makes sense to me that you have to think about what your model will be used for, if you'll be kind of, what's the word?
Abused.
Abused, yeah, abused certainly. But I was going to say, like, if your data has been annotated by humans, there's like some amount of human bias there. Obviously, for like, is this a 6 or a 7? I don't know of any like standard bias against 7s or 6s, but maybe there is. But certainly for other use cases, like human bias is probably going to shape your annotations to a greater or lesser degree.
Right.
And it's good to keep that in mind. The book didn't really talk about how to get around that. But I guess that's for a different book about how to like get non-biased annotations.
Did Claude come up with that line? Models can launder human biases into a veneer of objectivity.
It did. As far as
I
I know, I don't
mean,
No,
think
the
that.
word launder was definitely in the book. I
oh,
Oh
remember
okay.
yeah,
seeing that. Yeah. I don't know if that particular sentence, but he did use the phrase launder, which I
you're
triggered on
right.
that
You're
because
right.
it's like, yeah. I remember that
That
because it's
makes
Right.
like,
sense.
it sounds like a criminal activity, right? It is. It's like,
I mean,
But
that's
honestly,
pretty,
this
yeah.
is almost even better. Your model would be laundering and operationalizing at scale the worst aspects of human judgment with
yeah.
negative effects on the lives of real people.
At
So
scale, yeah.
yeah,
Leverage in
Yeah.
the worst way.
And
Yeah.
like, and pretending it's objective. That's
yeah,
also the key.
that's a
Right.
great
Like,
point.
mhm.
Yeah.
Yeah. Um,
And it doesn't have to be, I mean, that makes it sound like it's an intentional thing, but it's often not. Like sometimes it's just like you have to be careful. That's why it's just saying you got to be careful, right? It happens
for sure.
quite a bit.
Yeah, like I'm sure it's easy to walk into it without
Yeah.
even knowing. Uh, in your experience, does anyone look at this like, or is that just on? In some sense, I think probably like the people who are really good at deep learning and like understanding the math and all of that, like maybe aren't the most well tuned to like, I don't know, like is there like an ethics committee looking over models? Is that standard process or is it really
I
the
can't speak to
modelers
that.
can?
Anything I've done has always been, at like a company level, not at individual
Yeah,
level. And we've never
yeah,
had, I mean, yeah.
Well, I'm sure you've seen in the news like this deal that Anthropic has been resisting being used by the military, the US military. Uh, I don't know where it sits right now, but like I think that's probably a very salient example of this. Like cat's out of the bag a bit though. Like uh can they really stop them from using it? I don't know. But I think it definitely makes the point that the technology can be used as much for good as it can be for bad. I believe this example is they didn't want it to be used for like targeting sort of in drones, that kind of thing.
gotcha,
They
gotcha.
didn't want it to be like the sole decision maker or, right? They don't want it to be a decision maker deciding who dies, essentially, right? I mean,
Yeah, yeah,
who wants
yeah,
that? So,
yeah.
Okay, okay. Um, Collecting a data set is often the most arduous and costly part of a project. Uh, Having high quality data often matters more than than like how sophisticated or fancy your model is. I guess there was a paper called "The Unreasonable Effectiveness of Data." Haven't read it, but it seems like one of those landmark papers. It basically says that if you have time and money, your model will probably perform better if you just go get more data to feed the model than trying to spend that same amount of time and money trying to figure out the architecture of your model, hyperparameter tuning, things like that. So more data is good. There are different ways to get annotated data. For example, if you have a bunch of images, but you're not sure whether the image contains a cat or a dog, you can, of course, do that. Anyone can do that. It's not very specialized skill. There are things like Mechanical Turk, which was new to me, which I believe is an Amazon enterprise where you pay people around the world to look at your images and annotate your data. So if you don't need expertise, things like that are a solution. But obviously, the more specialized the task becomes, I think there was an example of like identifying cancerous cells or some medical thing that obviously you would need a medical degree to do. Annotation is going to be much harder in the sense that you can't distribute it to the masses. And they need
Ron,
domain expertise.
I think a couple weeks ago you were talking about a way of deciding like what to annotate. Like you were
Oh,
mentioning,
right.
I wanted to ask you
Yeah.
again what it was, and I didn't record it anywhere. Anyways, maybe put it in the chat again.
Yeah. Adaptive learning, I think was what it's called.
Okay,
But yeah.
adaptive learning. I'll look it up.
Yeah. I keep saying Bayesian optimization, but they're related, but it's adaptive learning that you actually want. Because Bayesian optimization is kind of like a adaptive learning, but you're actually trying to optimize something. So you're trying to optimize some landscape. So, but you can only, but data is costly to collect. So which, I collect a couple points. I'm like, okay, what data points should I collect next? And so I have to come up with some kind of estimate of what the landscape looks like so far to figure out where to pick the next point. It's not just whatever your model fits to be the most maximum, but it involves how much uncertainty there is as well.
Is
So you
that
adapt.
like you want to oversample if possible? Like you want to sample where there's more ambiguity between the
Right.
dividing
So
line between two
there's a
categories?
yeah, there's like this trade-off between, exploiting and searching, right? That's the old trade-off. So some places you don't really know very well. It could be bad. You should maybe you should spend some time over there, but there's some places actually are better with a little bit less certainty. Maybe you should probe more up there, that kind of thing. That's the Bayesian optimization. The adaptive learning thing was more about instead of optimizing some function, you're trying to improve your model, which I guess is optimizing still, kind of optimizing how the accuracy of the model is. But like, what is the next point? What data should I collect would help my accuracy the most, kind of thing. So maybe I'm talking myself into the fact they're very closely related, but adaptive learning is the more general thing.
Okay.
And so just to summarize that, the idea is data collection is expensive. Is there something I can do so I collect the data that's going to help me the most? Or at least I hope will help me the most. And there are some things you can do.
Okay, cool. I've written it down too to check it out because it sounds powerful. Yeah, I groaned at this one because in the past I have had to, there's been like no one else in my company to label data, so I have had to label data myself, which is not a fun process. Um, but at any rate, let's move on. We have to beware of non-representative data. The data we use to train our models should resemble as closely as possible the data that will be fed to our models in the production environment that will be passed to the model. Example here that the author used, well, these two. One was this food app example, looking at images of like restaurant quality, food magazine style photos, beautifully taken, to try and categorize food photos people take on their smartphone cameras just in daily life. And obviously those are a different subset of like highly curated versus amateur photos with lighting and framing and all that stuff. So the model did poorly on these more casual photos because they weren't in the training data set. The training data set was all like professional food photography. It also introduced, sorry, go ahead, Ron.
Sorry, just clarify. It's active learning is what they call it. Adaptive learning is yet something else again. Sorry. There's all these terms like you've getting messed up my poor little brain, but active learning is the thing you want to look up.
Okay.
As I was saying, I'm like, I don't think that's right. It sounds like I've got that slightly wrong, but I
Okay, we have gone from Bayesian
optimization, which is a cool thing
optimization
by
to
itself.
adaptive learning to active learning. We'll see
Yeah.
if we go anywhere else or if that's the end of the road.
That's the end of the
Okay. Okay. Good
row.
stuff. Oh, lots of things to look up. Um, there's this idea of even if you have representative data, that's like fit
But
for purpose. Sorry, go
by the
ahead,
way,
Ron.
do you mean to be showing your slides again? Because we're not seeing them. I don't
Oh,
know.
what do you see?
You.
Oh,
Wait, I can see
I
the
see the
slides.
slides too. Yeah.
Oh, maybe it's
Yeah.
me. Oh, never mind.
okay.
I didn't realize there's two tabs at the top. One of them says meeting, the other one says your screen. So never
Okay.
mind.
Okay. Awesome. Um, even if you have great data at the start that will match the production data you'll be receiving, there's this idea of concept drift over time. I guess the nature of your data might change. Their example was with a music recommendation engine. Music's constantly being released. The, I guess, associations between different genres change over time. And if you are still relying on a music recommendation model from like the early 2000s, you're going to get way different recommendations than a model trained using today's genres and associations. So even if you have good data now, you have to like ask yourself regularly, is the data still good or has the landscape changed? Sampling bias, data collection process interacts with what you're predicting. I don't remember the example they used here. Was this the
I can't remember either.
who's the president? The president Truman, Dewey? Or is that
Oh, right. Yeah, the election result. Right. So that's because they were doing telephone surveys. So
yes.
yeah, now
Yes,
I do
the bias
remember.
was they weren't getting the full
So
snapshot of
the
American voters. They were just getting people who had cell phone or
telephone.
telephones, not cell
Yeah.
phones.
Right.
Um, again, just a general statistics thing. Make sure the data you are collecting comes from the population you think it is meant to represent.
Or know how to correct for it, which I guess is the other way, right?
True, true. Like with what would you say if I were to look something up? Like weighted,
Stratification, I
stratified.
think. Yeah.
Okay,
Yeah.
okay. Um, when you get your data, don't jump into modeling right away. Like do an exploratory data analysis, plot some histograms, plot some bivariate plots, try to understand what's associated with what correlates with what. Um, check for missing values and handle them however you think is appropriate, like mean imputation, using the mean, using the lag or lead, whatever I guess is appropriate to your use case. And when you're looking at all of your features, the predictors in your data set, watch for target leaking, which is when some feature gives some information about the target. I can't remember the
I mean, it's kind of a funny thing to say because you're hoping the features do give some information about the target.
that's correct. Yeah.
But it's like information that shouldn't be there that you wouldn't have. The way they put it is it shouldn't be if it's not something you would find in a real data set or in your test set when you're using the model in deployment, then it shouldn't be in there, right? I can't remember
Yes.
the example either, but yeah.
The
But it could be just
example,
something blatant like this is a cat. What is that doing in
yeah.
there? Yeah.
The example I think the book provided is that if you have a feature that is like this person was diagnosed with cancer, and then you're trying to predict cancer, does this person have cancer? Like that's
Right.
obviously
Yeah.
so maybe that's a little like overly simple, but yes,
But
you
especially
know,
when you have like text fields, sometimes that kind of stuff, this putting it by human, that kind of stuff can definitely leak in.
okay,
I can give another example that's because this happens to me a lot also. It's sort of like the cancer example, but often I'll be asked to identify missed patient groups. So let's say somebody who came to the hospital for stroke, but wasn't identified properly as a stroke patient. uh, often like the signals of that clinical workflow are in the health record all over the place, and you just don't realize it. So you've got to actually like specifically remove all these indicators of a clinical workflow that are essentially proxies for a stroke patient, like certain kinds of imaging, certain kinds of medication administration. So, like, if you
Uh,
truly want to find those missed strokes, you have to like deplete from your data set all these indicators of that clinical workflow. Which is sort of counterintuitive, as Ron was saying, because like you that's exactly what you want to use. But if your intents if your purpose is to find missed cases, you essentially have to remove anybody that was already identified or might have been identified properly, which means you have to like force yourself to rely on variables that in no way are proxies for the clinical workflow that you're looking for.
Okay, that's actually very helpful for me. So thank you for sharing that.
Mhm.
Um, and I think I was asking you, Madeline, about this when you presented, but like, how do you choose a success metric? Um, how are they different than the loss function? These success metrics mean different things, and maybe the people who ask you for the model will know what they want, or you can help them understand. But you basically just want to make sure your metric is aligned with the business goals, whether that's to maximize or minimize like false negative or minimize false positives or have different metrics. I'm not very familiar with all of these, but I can imagine circumstances where it's better to, where you definitely don't want to miss false positives or false negatives, but you also really, or then another situation where you don't want, having false positives is very costly, either because you like take some extreme action to them. So just understand, I
yes.
guess, what is more important to the business case. Custom metrics are common in practice, which surprised me. Kind of as an outsider to all this, like I don't know, these all sound so fancy. Like I know roughly about them, but like they just seem so fixed in books and texts that I read. But
I can see like in a medical field, especially that, this would be challenging because sometimes the cost of false alarms is very subjective, or same thing as well, particularly the cost of missed positives, right? You're talking about lives at some point, so it's
yeah,
like it's important to like phrase those things properly. I imagine for the stakeholders. I know from things I've done in related fields that's been the case, and I've always tried to frame things in a way like, hey, you as a stakeholder get to decide where you're going to put that detection threshold because that's not up to me. You have to decide how you want to balance that thing.
totally.
I think too, like again, just going back to the example that I gave, often the stakeholder will want one model to do two different things, and it can't. And you
Right.
kind of need to
Yeah.
communicate that to them using precision and recall and that kind of thing. Like if your goal is to find missed patients, you have to accept that your precision is not going to be very high, but your recall is going to be good.
Yeah.
And that is one certain kind of model. Whereas if they want high precision retrospective reporting, so basically catch everybody that we know about, but let's not have to screen or look at anything but we what we know about, like that is a different model also. So like absolutely everything on this slide. And often you end up having to explain what they mean to people who you assume know what but again, this is like eliciting what people actually want and need from you, I think, that is more complicated than at first glance. And absolutely custom metrics are common. Like often, as I said before, I'll be told what I have to report on. I can't train on that, but I have to report on it because somebody somewhere has decided that is how they want it to be presented to them. Usually some executive.
Gotcha.
So, yeah.
Okay. Um,
I always forget what those things are, by the way, because I don't use them all the
okay.
time. So I always go to the Wikipedia page, has that like there's like a diagram that everybody knows, like got like a circle and a square and it's shaded. It helps you figure it out. Look it up
Okay.
on Wikipedia.
I'll have to check that out because I also have to look them up every single time.
It's like, what's the denominator and what's the numerator on these things? I always
Yeah.
forget.
Okay, we're officially in part two of the universal workflow for machine learning. We're developing a model. There are some feature engineering steps you can do to scale, normalize your data into a format that, or into a form that your model will handle better. Obviously, converting raw text or images into tensors is something we talked about, I think, in the first chapter. I don't remember if we talked about normalization uh, in a previous chapter, but again, a standard statistics thing to get your values, I guess, on the same scale and with the same standard deviation. So everything's between 0 and 1, and everything is mean of 0, standard deviation of 1 if it's numerical, and I guess everything's numerical in the end. Handle missing values, categorical new.
Do you remember he mentioned in the book like there's a possibility of data leakage here with the normalization step if you're not careful.
That sounds vaguely familiar, but I can't remember anything more about it.
The idea you always use your whatever your test, whatever your training set, standard deviation and mean are, you don't like use the you don't recompute that for your test set type thing. Otherwise that causes some
Yeah, yeah,
leakage.
yeah. Because you're telling your test set basically what the mean and standard
Yeah.
deviation of the training data are. Okay.
It might be come up later. I don't know.
Isn't that you like do the normalization, you do these steps independent from your test and your train? Like you don't standardize, normalize your train and test together. You do it
Right.
separately.
Right.
Yeah, that makes
Yeah,
sense.
that's it. Yeah, that's what it was. You got it.
Yeah.
And on the last part about handling missing values, I think what the book says, you can create just a new missing category if a predictor, if the feature is categorical, and like you don't need to do any sort of imputation for a categorical variable. You just leave it as missing, and the model just treats that as another category and handles it um, in ways I can't really speak to more intelligently, but it seems like a solution.
Yeah, that works
Uh,
well. That does work well. I've done that before.
I guess it would be weird if you had like data that was missing. I guess like all the missing data is not the same, presumably. So
There's this concept of informative missingness. So the very fact that it's missing is informative versus just purely missing data. So I think of like clinical workflows that need to happen very fast. Like there's just no time. So the very fact that the missed data is missing indicates that it's a certain kind of, for example, patient where things are happening very quickly. So actually, that can be very useful to help identify certain patient groups. And then in other cases, you've just got data that's for some unknown reason, just somebody didn't enter it. And those are kind of separate. But there are
okay,
cases where missingness is quite informative.
okay, okay. Thanks, Madeline. That's very helpful.
Right. There's actually a whole concept of like, is it missing at random? Is it missing not at random? Is it missing
Yeah,
at completely random? And the nice thing, like some of these machine learning models, is they just will you can just put in the missing and it'll just try to kind of figure it out because it's not a causal model; it's predictive, right? Now, if you're doing causal analysis, that's quite a different thing altogether. You got to be very careful. But
okay.
and
Um,
I like the outcome. I know I harped on this before, but I just kind of remind you, like a lot of these things we're talking about in this book are predictive models, right? So predictive models are like, hey, I want to be able to predict if it's raining outside. So if I see umbrellas, it might be raining. It's not a causal model, though. Adding umbrellas does not create rain, right? So you just gotta be careful of that type of thing.
yeah. I think I would got
And
hung up on that for sure.
so missing this for cause and all that is missing this can be informative, which can be a bad thing because it might produce some causal connections that aren't supposed to be there. But for predictive models, it's fine, right? It's actually helpful. It's like, great, this missing this helps me make a prediction. Perfect, right?
Yeah.
On,
Okay.
I'll just say too, like that actually, what you're talking about there is like a bit of a paradigm shift for people who come from a background that was mostly inference based. Like, I don't care if my data is dirty. I don't care if it's there's errors. Like if the gold star is it can predict the outcome that you want well. Like I will say a lot of people in healthcare are very preoccupied with making sure that the data is collected exactly so just properly. And I'm like, yes, great, I agree. But also, if the tool that if like if you can get the prediction working well, who cares?
Yeah.
Within reason, within reason.
It depends on what kind of decisions you're making with the
Yeah,
prediction, right? If your decisions are like what kind of shift sizes I'm going to use at a hospital, a predictive model is exactly what you want. If your
yeah,
decisions like what drug should I give a patient, that's not going to be a good model to use.
agreed, agreed.
Yeah.
When it comes time to evaluate the model you've created, you have different methods, which we talked about at least a couple times throughout this book club. I believe holdout validation, k-fold cross validation, and iterated k-fold. Um, Always ensure no redundancy, that they're totally separate. The training and validation sets, and that your data is representative across all of them, all those different sets. I guess your job in the workflow, okay, you've figured out the business problem, you've started to create a model, like the push, the focus seems to be on just getting a model that can beat a baseline, whether that's from a previous model. You can focus on three things to try and beat the baseline: feature engineering, which we talked about a bit with the normalization and scaling and stuff like that, and mean imputation, architecture selection, whether you do a dense network, a convolutional neural network, RNN recursive neural network,
Yep, you got it.
or transformer, training configuration, what loss function you decide to use, the batch size, and the learning rate, how big those steps the model takes or the gradient descent takes. There's this table. I think this is a table pulled basically directly from the chapter about picking
Yeah.
the right loss function for the task. You have the sigmoid, which I was watching some other videos. Some person said that sigmoid is kind of like old school. I'm not sure what grounds they made that statement on, but
That's so it is for activations in internal layers, and then that's where RALU, as Eric
oh,
always
okay,
said, or leaky reuse and all these kind of things. But sigmoid is, you also call it logistic regression. It's the same kind of
yeah,
thing used in logistic regression. That's still used on that
for the
last
last
layer
layer.
for binary. Yeah,
Okay, okay.
it just maps the real line to 0 to 1, right? That's what you need. Something that
Yeah,
does that.
yes, and that works for classification because it just gives you a probability that this image
Right.
is of that class. Okay. And ReLU, for example, doesn't. It
Yeah,
does
that's just for act. That's
zero.
just it's just adding a nonlinearity to the inner layer. So
Okay.
yeah,
Okay.
which you
So you have your task, you have the last layer of your activation. So depends on your business task. The loss function. We haven't really talked about entropy a lot, but I've seen that come up in some other books and videos. I don't know much about it, but seems to be the loss function to use for classification problems, at least.
it's a measure of the difference between like two probability distributions, right? That's why it's
Okay.
used. So
Okay.
you want
I
you
did
want
not know
your
that was it was,
you want
but
your probability distribution that you're predicting your model produces be as similar as possible to the real probability distribution.
that makes sense. That makes sense. And then you have some metrics, and you can provide multiple metrics, unlike a loss function where you can, I think, just choose one for your particular model instance. You
Yeah.
can report on as many metrics as people want.
I mean, you have one loss function. It could have other terms in it. You could have like you could combine two loss functions and add them together
Okay, yeah.
with a hyperparameter. That's done quite often.
Oh, really?
Yeah.
Boy, that
Well, I mean, the
sounds
simplest case is like the regularization, right? The second last loss function is just squaring the square of the or the absolute value of the parameter, right? L1 and L2 regularization. That's all it really
okay.
is.
Okay, that's helpful because I didn't actually understand those super well the first time we talked about them. Um, Scale up, then regularize. What does that mean?
What do you
Oh,
mean?
okay. Overfit intentionally. This is part of the workflow is you want to produce a model that overfits for reasons that still aren't super intuitive to me, but with only 12 minutes later, I think that's just reading I have to do. Um, you add more layers. You make your layers bigger. Not
Yeah.
quite sure what that means, but and then you train longer by adding more. Like I know you add more epochs to make it train longer, add layers, but is this batch size?
No, that's just
Talking about?
bigger internal, bigger hidden layers, right?
Oh,
So
really? Okay, so it's
like it's,
basically the same thing as add
yeah,
layers.
we'll make them wider is what
More
like
nodes.
Oh, yes, yes. Okay, yeah,
so
I
it's
get you now.
16 or 32 or 64, right? 64.
Yeah,
Remember, it's a transformation. So you start out with like let's say, I don't know, a 10-dimensional vector that represents your data. Then in the inner layer, now in the hidden layer, you've got maybe a 512 dimensional vector, right? And
yeah,
then the
yeah,
mapping
yeah.
between them is that
I
matrix.
do remember that now. So thank you. Uh, then you regularize. So first you scale up, make a big model, then you regularize. I don't know if I have anything insightful to say here, so jump in if you have anything insightful to share. Otherwise,
Not really. I think we did talk
let's
about
keep
this
it.
last week too, I think.
Okay.
I think.
Um, Once your model's, I guess, scaled up and regularized, you want to train it on, you want to train it. This is the first time I'm reading the slide. It says you want to train the final model on all available data, training plus validation.
I mean, if you want me, I can just lean in here.
Yeah,
The
please.
the idea is that you've got this training set, and you've got this validation set, and you're messing around with things, and you're trying different model sizes. You're tuning the training, the learning rate. You're tuning when you're going to stop it. You're tuning the dropout percentages, and finally you think you got the best model you can do on the validation set. Now you combine the validation and training set together and train on all that data, right? Not the test set. You still have that held out. Retrain the model as configured, as you've now configured it, what you think is the best you can do, or maybe a couple different versions of this, right? It's kind of cheating, but people do that. And then evaluate on the held up test set.
Okay. Okay.
Ideally, you
Uh,
have one model, you're like, this is the one. I've checked it, I've compared many different models on the validation set. This is the one that does the best. Now I'm going to retrain it on the all the data I have except the test set. Then I'll evaluate the test set. And
yeah.
then I guess you're at that point, you're like, okay, report it and hopefully it works well. If it doesn't, well, I'm not
Okay.
sure exactly what you're supposed to do. I know what I do, but I know what you're supposed to do.
I guess I'm still confused about what the purpose of the validation set is. Is that to like hyperparameter tuning?
Yeah,
Yeah.
it's how you score your, or look, you have a model, you want to evaluate how well it's doing. You have to do it on data you didn't train it on. So that's the validation side. It's not, originally you're not training it on, only at the very last step do you train it on that.
Okay. Okay. That's a little clear.
Yeah.
Now to deploy the model. Um, as with any time you're delivering data science, statistics, modeling stuff to non people who aren't as familiar with the lingo, don't just say the model has 98% accuracy. Give like examples using of 100 images, we will falsely identify 3 cats or something. Like put it in simpler, easier to understand numbers. Uh, Discuss launch parameters. I guess those are the parameters start that you deploy the model with initially, and then you can tune them down the road. But these are the probability thresholds. And what that means, if you're trying to, you have set the threshold for, is it a cat or a dog, I think, and how your decision about what that threshold is will shape the outcome. And somebody's got to own that. Maybe not for that silly example of cats versus dogs, but if it's, do we treat this person for a disease or do we not treat, or do we
Or going to,
regulate
yeah, or going
that?
to
Like,
another level of testing or whatever, right? Yeah.
there are consequences. And I guess someone has to own that decision. You can deploy your model a bunch of different ways um, with REST APIs, which from my reading were like the standard way to do it. But if you need to have your model on a device that is not connected to the internet or just has poor connectivity, you might want to do something like TensorFlow Lite or Onyx Mobile. I forget what the acronym is, but
Me either.
I guess none of these really speak to me. I don't have any experience with any of them, but if you have basically different options depending on your use case, then when so I think this is inference optimization is about the step where you have a model, but you're trying to simplify it so it'll fit like on a small memory device or run faster, possibly. And these
Right.
are two things you can do uh, to optimize inference, where inference means prediction, which is kind of not how I thought about the word inference uh, outside of that.
It's like it's
I
taken on a different meaning here.
I agree. Yeah,
Yeah.
it's kind of been hijacked in this field
Hmm.
this way, but yeah.
Okay. Glad I'm not the only one who felt a little.
Inference means forward pass to the model essentially, but yeah. I don't know why it's called
Yeah.
inference. What are you
Yeah.
inferring?
Okay. You can do weight pruning, where you just remove low impact parameters. You're trading accuracy for size in that respect, where you have a less accurate model, but it's smaller. So you decide what you need most. Also, weight quantization. I've never seen that word before, but you're basically just taking a more complex number with more decimals and simplifying it, I think, to a lower precision number. Um, if you deployed your model, whatever, however you deploy it, I guess you got to monitor it, or somebody has to monitor it. Uh, you want to do A/B testing, I guess, at the launch specifically. I don't know how much A/B testing is used as like a monitoring versus an initial check, but you want to do A/B testing to see if your model has impact. Show it to some group of people and show the other group, I guess, the no model version of whatever it is you're building. You want to do manual audits, checking in on your data, have users of your model weigh in on how the model is doing, the surveys, and also watch for concept drift, that idea that the data your model is trained on becomes less relevant as time marches onward. But you also, at this time, should be preparing the next generation of your model, which involves new data and new architecture and new techniques and all that. So to recap, this is the universal workflow for ML. You define the task, which is often, I think, the biggest and most like wading through muck, in the sense that you don't really know what direction things are going in. It feels like you're pulling teeth sometimes from stakeholders. No one is clear why conversing is so difficult to get the information you need, but that's that task. You then develop a model and deploy the model. All right, discussion questions. Sight unseen for me.
That's what I do.
Uh, yeah, it's kind of like, well, what are we going to get? Which phase of the workflow do you think is most underappreciated in practice? I'll let that hang for the group and someone can respond.
I mean, I think I've said what I think is probably the upfront stuff. no matter how much time you spend on it, you probably haven't spent enough time on it.
Yeah, I think that's my answer too.
Hmm.
I mean, I would have to agree, but I mean, I don't really haven't done much of the deployment end, so I wonder about that. That's going to probably be a big surprise how much pain that is too when I have to do that.
Yeah, it's mostly a
Right,
surprise
Maxwell?
when you discover there's no infrastructure for it. But also, I would say, like, there fundamentally for me, I had to get my head around the push versus pull deployment. Like the REST API, it's essentially asking for an answer versus you pushing out an answer. So, like,
Right.
batch scheduling of your model, let's say, is pushing out on a schedule versus the rest, which is like essentially pulling based on an event. So, like, there's like I think a difference there that the book didn't, I don't recall really discuss, but I encountered when I was like, oh, those are fundamentally different in how they're operating. And most of the stuff I do is batch scheduled running of the model versus REST because of, yeah, again, it's locked behind, proper firewalls and everything.
Okay. It sounds like we're all in agreement there. For two, how would you handle the concept of drift in a project you've worked on? I've never worked on a project where that's really been the case.
I
I don't know if
mean,
anyone has one they want to speak about.
it's not an if, it's a when. Um, Often you can just like for at least in my stuff, for example, you can just refresh. Like let's say you train on the last 6 months of data, you just like retrain on the another more recent data cut, and often you'll get back to the performance that you were at before, unless something has structurally changed, fundamentally changed, that requires new variables, that kind of thing.
Okay, that makes intuitive sense to me.
Hmm.
Do you find that I'm really new to this field, so I don't know how often say new things like RelU or like leaky RelU or like these activation functions, like at what cadence are they dropped where you might be like, oh, I should check out what the new activation functions are to see if they're better, or like, are we pretty fixed? I'm
I
just using
can't
activation
comment on
functions
that.
as an example.
Yeah.
Okay. Um, when is deep learning not the right tool for the job? I don't have anything insightful there to say other than
Almost never. No.
yeah.
Never. Uh,
No, I
That's
mean, I'd say
fun.
really opposite. I'd say I find I rarely use deep learning. I mean,
yeah.
I find I have a few cases where I've needed to dig into that, but for me, mostly this is kind of academic. Um, it's interesting to me. I find it really fascinating, and I've certainly used deep learning tools quite a bit, as you know, we all have, right? Claude and image generation and all those kind of things. But I think it's important to keep your toolbox, what do you say, current. That's what I'm trying to do here.
Yeah.
For
Hmm.
me, the toolbox, the tool I normally reach for is Bayesian inference for almost any questions I have.
Okay.
But I'm dealing with
Gotcha.
small data mostly.
Gotcha.
Yeah, I think having read this far in the book now, I came to the conclusion that, yeah, there's going to be very little application for me with deep learning. But again, like Ron, it's interesting to learn new methods and that kind of thing. Definitely the machine learning, um, but not really a whole lot of deep learning. And then all the cool applications are already built into like for example, imaging, like or software that captures imaging, like medical imaging, for example. Like it's built the deep learning is built into the
Yeah.
software, and they're charging you for it. Right? Like, yeah. All the
Yeah.
applications I could think of are actually already being delivered by somebody who's not smarter than me, but like probably doing a better job than me. Yeah.
Yeah. So, I've used like, OpenAI endpoints, to uh, take some data that did have some text columns and turn into categorical things that I can actually use in my regression, for example, right? So somebody describing something in like a big long verbal or a big long text field in this basically big giant spreadsheet, and I can't really use that, but using OpenAI language models, I could turn that into something I can use. But I didn't train the language model,
Hmm.
and I didn't even
Yeah.
have to know how it works. It just works.
Yeah. Yeah. I've done the same thing
Yeah.
to like structure text data, but
Yeah. That's structured text data. That's a much better way of saying all that word salad I gave.
Okay. Well, I guess we can wrap it there. Thanks for the discussion, folks.
Yeah, it's good. Really good. It's a good chapter, I think. It does. It was great. I think I'm really happy to put a chapter like that in there to say, look,
Yeah.
we're going to spend most of this thing on step two, but be aware most of your life's going to be on step one and three.
I also feel like it was a nice chapter to kind of like take a
Yeah,
step back
right.
before we go on break.
Right. And then we're going to dig right in.
And to
Yeah.
Karis, yeah.
Okay. Well, thanks so much, everybody. I'll see you at the end of March.
Yeah. All
All
right. Good
right.
one.
Okay. Take care, everyone.
Okay.
Bye.
Bye.
Bye.